So, welcome everyone. Nice to see you here. Hope you enjoyed the conference so far and also this talk. Maybe to start a little bit with an introduction about myself. My name is Markus. I'm a software architect working for a company named Salomon Automation. We are part of the SSI Schäfer group. That's a privately held group with approximately 9,000 employees, somewhere between 9 and 10,000. Approximately 700 working in IT, and approximately out of that 700, 300 working parts with Eclipse. We are creating a software named WAMAS, that's short for Warehouse Management System, so we're dealing with intralogistics and actually managing warehouses, managing everything that happens inside a warehouse, keeping track of stuff, moving boxes and pallets and stuff like that. So basically, if you have a look at the warehouse, WAMAS is responsible for everything that happens between the incoming and the outgoing gates. So everything that happens in there, that's managed by an Eclipse application. So why am I giving this talk, or what am I talking about? So this talk is a success story. We have been around for like 10 years now and building software with Eclipse and based on Eclipse. And we're pretty successful with that. Actually, our developers are satisfied, our customers are satisfied, so that works really good. And we want to give a little bit of information, at least information, back to the community, and also tell you how we managed to survive 10 years of Eclipse. So for sure, not everything in this talk will apply to everybody, but please feel free to pick up ideas, and as I will mention later on, we're open sourcing some of the things that I'm talking about, so this is going to be available pretty soon. So actually, 10 years back, it was rather this situation. When we started with Eclipse, we had some issues. Not everything was working pretty well, but we managed to somehow get to this by just getting our hands a little bit dirty and enhancing Eclipse. So for us, what is scalability for us? So we have thought about this when preparing for this talk, and actually we identified 5 different dimensions of scale that are relevant for us. So the first one is the size of our code base. So we have currently like approximately 3 million lines of code that are handwritten, distributed among nearly 800 bundles. Along with that, an additional 2 to 3 million lines of code that are generated from models. So we use a lot of model-driven development. And that makes a pretty huge code base, actually. And to make it even worse, all these 800 bundles are in the workspace simultaneously. So we always have all the 800 bundles in every workspace. So you pretty soon hit some scalability issues with this kind of setup. We have approximately up to 200 developers involved in all this. These are product developers and developers that pick up the product and tailor that for each project's need. So for each project, there are a lot of adaptations. We employ more than 15 major Eclipse technologies. So there are a few like Xtext, RAP, EMF, and these kind of things that we use. And even a lot more smaller stuff that we pick from the community and use in our IDE and application. We have quite a lot of nightly and CI builds. That's also something that's, you need to be able to deal with that in some way. Yeah? So your IDE needs to be prepared somehow to be easily installable, provisionable, updatable, whatever, so that you can have a lot of these CI builds. We have right now, that's a number that's for the time frame of the last 3 years, actually, 11,000 installations of Eclipse in our company. So that's the total number of launches of the install wizard, so to say. And that's the other number. Only 10% of these 11,000 installations are used actively right now. So we're keeping track of that a little bit, just to give us some knowledge about that. We have worldwide customer installations that run 24/7, so there should not be too many problems around, yeah, so we don't have to work all night. And per customer installation, we have, it heavily depends on the size of the warehouse, between 50 and 1,000 Eclipse processes running, so Eclipse platform processes running. Maybe as a side note, database sizes that we have, relational database, are between 10 to 7 terabytes, or 10 gigabytes to 7 terabytes. And we have a lot of attached devices that are not directly running Eclipse, but a pure Java application currently. That's a mobile application. These are the small devices with which you can run through the warehouse, scan pallets, and do all the mobile processing and stuff. So that's connected through RPC to our application. So we have 5 dimensions. Where should we start in optimizing? Where should we have a look first? Actually, everywhere. There is no way that you can optimize only in one of these areas and the rest will just work magically. You need to invest in every of those areas, or we needed to invest in all of those areas to be able to scale. So we derived actually 3 major building blocks that we need to tune and tweak to be able to scale in these dimensions. And these are IDE, platform, and deployment. And to be able to scale in the different dimensions, we need to invest in the certain areas and make them better and stronger and stuff. So we did a lot of extensions to the IDE, we did some extensions to the platform, and we have solutions for deploying Eclipse and our application. So the last few years, we actually did quite a lot. We programmed a lot of extensions for Eclipse and stuff, but that's a little bit too much for today. So I picked out a few, and that's what I want to show you today. In the area of the IDE, we are centrally managing the IDE, and this is actually a very important point for us because it allows us to centrally configure an Eclipse package with all the additional software preferences and stuff, default preferences, and roll that out to the developers. And that's, for us, done with Genuitech STC. That's an Eclipse-based, also an Eclipse-based commercial software that deals with packaging up Eclipse. And we're also, as you're going to see later, using the same software for provisioning, distributing, installing our own software. So that's why we use it for Eclipse too. Otherwise, we could, for instance, also use oomph. So there is not much would hinder us. So this looks somehow like that. We have a lot of IDEs. We have one IDE actually per branch. So we do this to really have a state that we can reproduce. So if in 10 years somebody needs to fix something in release 5.4.4, he can pick that IDE, he can check out the branch, and everything is reproducible. So that's very important for us, as our software has lifetimes for up to 30 years in production. So that's not so easy handleable. This is the STC Admin Console. You can very easily create packages and maintain them, add additional software. You can do workspace setup tasks. So whenever you launch one of our IDEs on an empty workspace, a wizard will come up and guide you through the setup process of the workspace. So we did a lot to really speed up the process for developers. We have some tight integration with version control. This is the wizard that actually pops up when you start Eclipse on an empty workspace. It already has the URL of the repository pre-configured, so you just need to press OK, and it will clone the repository, and it will then allow you to select the categories that you're working on. To be honest, it does not make very much difference what you select, because you have like the base 500 bundles that you will get anyway. But for the rest 300 bundles, you can choose a little bit and tweak your workspace setup. And in the end, once you press finish, then your workspace is set up, you're ready to go, everything is categorized in working sets and stuff like that. In the background, this works by a configuration file. This is actually a very, very simple file that is checked in along with the source code. And the IDE will read that file and then import projects and categorize them in working sets and stuff. this is going to be the biggest topic for today. That's unified build infrastructure. This was something that was very important for us. So previously, where we came from, we had just as usual, no actual build mechanism for the IDE. So inside the IDE, there is the Eclipse auto build. It will build your projects, and yeah, you're more or less happy. Problem with that is that there is no possibility there was no possibility for us to integrate our code generators. We have a lot of code generation, and the generators actually are applications inside our workspace. So it would be possible for in Eclipse to integrate builders on projects that can run code generation for you, but in this case, the generators must be part of the IDE. In our case, the generators are part of the application and are using our platform to actually read the models. This was not easily solvable at all back then when we started. So the typical workspace build for a developer was to clean everything, let the auto build run for a while, and then everything was red and all the errors around and stuff. And then you need to run the first code generator, then again Eclipse auto build and let it work for a while, and so on and so forth. And this repeated 3 or 4 times. So, and a second issue with that was for the nightly builds, we actually had ANT scripts that could do a single build for our software, but we very often had the issue that the ANT build had issues where the IDE build did not have issues. So problems that only occurred in the ANT build, or problems that only occurred in the IDE and not in the ANT build. So these separate configurations, they were a huge problem for us. And I saw a good example at one of the talks at the EclipseCon here, where the version of a bundle should have been upgraded, and he had to change the version in the manifest, and in the POM, and in the feature, and in there, and blah. So this is something that we really wanted to get rid of. So for us, right now, it's all metadata in the OSGI bundles. So there is one place to configure the version, one place to configure dependencies, and so on. And we invented something that's called WAMA's Power Build right now. It will be rebranded and open sourced in quite a short time. And basically it deals with, or it was invented for building our software. Pretty simple. We are reusing the Eclipse build mechanism. So what it essentially boils down to is that we call project.build. That's it. The only thing that we make different is the dependency resolution. So we're calculating a build graph up front. It takes for our 800 bundles like 50 milliseconds or something like that. And we are able to inject additional steps into that build graph. For instance, our code generators. The code generators can define, I need this bundle to be built so that I can run, and I'm producing more code in these bundles. And then the build graph will automatically put the node at the right point and execute the generator at the right time. The second greatest thing in here is that it can be run from the IDE and from the command line the same. So there is a command line application which you can simply launch, and it will do exactly the same thing. So if I press this button, full build workspace, or I launch the task chain workspace from scratch, then it will produce exactly the same result. And that was something, this reproducibility was something that we really wanted to have. Another thing regarding this dependency resolution is that we are using only require bundle information. And that is actually a crucial point, because evaluating import package is quite expensive. Import package basically means I need a package, I have no idea where it comes from, so please look it up for me. This can be really expensive, and Eclipse Auto Build has to take this information into account. Of course, the information might be there, and just the evaluation of this information makes the auto build a lot slower than just calling build on every project if you know the order. So we basically were able to get down to 4 minutes 50, something like that, on a standard notebook to build our software, a few million lines of code, 800 bundles. Previously, it took like 50 minutes. Not 15, 50 with the Eclipse Auto Build. Yeah, that's something that I just can recommend to everybody. Don't use import package. Even though OSGI says you should only use import package. The next best thing that we did was we were actually using UML models for our modeling stuff, and we exchanged that with Xtext. And this was a huge leap. It was really a big step for us, and it helped us a lot. So previously we had binary xml.zip UML models from a well-known UML software, and they were managed in an external repository. And this external repository, it's not associated with our Git repository, so we're using Git and Gerrit. And it's extremely hard to find the right point in time where you need to commit in the one repository and in the other repository so that everybody has a consistent state of the software and models at any point in time. So this is actually, it's impossible. Yeah? Any point in time you do it is wrong. Also, the mergeability of the models, of course, improved a lot. It was not existing before. So the binary models, you could not merge them at all. The text models, it's a piece of cake. And we were able to integrate a lot of our metadata actually into the language itself. So that's a huge benefit for us. We had a lot of metadata hidden in tagged values and stereotypes and stuff like that in the UML models. And it's extremely hard to maintain. So it's nearly impossible to discover errors and stuff like that because a typo in a tagged value, it's free text. It's just some textual information. You cannot detect any typos or stuff. Just not easily possible. And actually the only requirement that we got when we wanted to switch to Xtext was that we still need to be able to have the nice graphics, fancy graphics. We need documentation for a model, for externals and for a lot of people. And we need to be able to produce that. So what we did was we actually put a little bit of layout information into the language itself. So it's possible to describe a diagram in the language itself. And you can do this in a very, very abstract way. So you just say, I have these 10 different things I want to have on my diagram. This one should be right of that, and this one should be below this. And then the layout algorithm comes along and creates a diagram. Of course, this is a very simple use case, but I can promise it also works for dozens of nodes on a single diagram. Up to, I think the largest one is approximately 100 nodes or something like that. So it scales pretty well. And from there on, we can generate documentation, we can generate images, HTML pages with clickable persistence, so the boxes are all clickable. Yeah. So this was really, it was a nice project. It was fun to implement, and Xtext is really a cool technology, really nice. Okay, for our application itself, we are going with the Eclipse releases since 2007, always upgrading more or less to the latest Eclipse right in time. We delayed it a little bit in the last few years where we only switched to the .1 or .2 releases, just for stability reasons. But we only have a target platform since 2012. So before that, we actually used the running platform as target. And it was also a huge step forward to split these concerns. So not having everything installed in your IDE that your application needs is really a good idea, especially because we need a lot. So we were splitting out the target platform from our IDE in 2012. And actually, we were forced to do so because we wanted to migrate to Eclipse 4.2. And that was not really a good idea for our target platform. So we could not migrate our software in time for the next release to 4.2. So we flipped the IDE to 4.2, and the target platform stayed 3.8. And since then, we have the split target platform, and it really helps. So managing the software gets a lot easier. And I can recommend a handy tool from Obeo. Anybody from Obeo here? Nice. Good work, guys. Thanks. The target platform DSL and generator, this thing is really, that's really extremely helpful. So we're defining all our target platforms using this thing, and the PDE target platform editor is not so good. Next technology that we have and that works really great is RAP. So we had the requirement to bring our application to the web a few years ago, and we thought about what to do, which technologies to employ, and we researched a lot, and there were voices that said, oh, RAP, this is all not hype, and SWT is dead, and things like that. But in the end, it saved us really, it saved our lives, because we were able to just flip our application, shove RAP under the hood, and everything worked. Yeah? So we have maybe a few hundred lines of code adaptations in the platform, but apart from that, 5 million lines of code, boof, and it works. So we have like 800 SWT-based dialogues, and none of them, not a single one, has a RAP-specific adaptation. So this is really cool technology, works flawlessly. And you can have a look at the application. If you compare it to the desktop application, it looks essentially really the same. There are a few features that are not supported in the web application, for instance, copy-paste of single cells from the table and stuff like that. But actually, for the use cases that we built it, it's sufficient, and it works great. Then the next best thing was EasyF. Previously, we were using RMI for remote communication, and this actually is not such a good idea if you want to scale, because RMI has some limitations. It does not really work well with OSGI. It's not so OSGI friendly. It was the only plain Java application in our ecosystem that we had around. And also the RMI registry prevents actually scaling by enforcing you to have the registry on the same machine, physical machine, as the service that you're providing. So it's somehow not possible to register a service on another registry. We replaced that with EasyF, and we're really happy with that. There are a few benefits that come along with that. Like for instance, that you just have to define a plain interface for any remote service. With RMI, it's required that you extend remote. This is not required for EasyF, and that's really helpful. You just write your interface and publish a service, and that's it. Really, really simple. The last area is deployment, updates, monitoring. As I said before, we're also using a Genuitech STC here. It's actually built to manage Eclipse. We use it for that too. And we extended it a lot to be able to manage our RCP processes, our server processes and stuff. So basically we're pushing from our IDE. We have a button, build me an STC pack. It pushes the software to STC. It builds a pack that then results in some installers. You have nice wizards with the next finish experience, and maybe accept a license. And then if you install that to any STC server, WAMAS is available. You just have to configure it, and then you also get nice installers for desktop applications and stuff like that. So we have a really good workflow also for the developers to create the deployment of the application. And that's really important because you need to be able to do that fast. And also we have some integration into STC regarding hotfixes. So we also built some support to build mini packages, mini features with only a few bundles, push that to the server and apply it to the existing installation of WAMAS. And this really helps to keep the turnaround times low. So for a hotfix, typically from the point in time where I change the line of code in the IDE to the live system, even if it's remote, that takes under 2 minutes, including restarts and everything. So that's really a nice thing to have, important thing to have. And we also can monitor our processes both from the IDE and from this admin console that you saw before. So we see states, is it running, is JMX reachable, is the debug port reachable, and stuff like that. This looks like this. This is the STC Admin Console with our extensions, so you can basically configure the system by setting properties and configuration values for each process. We have quite a few. And then you can monitor the system, having a look if everything's running and stuff. We also have some integration from the command line to this, so you can also steer this headlessly. And we need this, for instance, for cluster support. So if you want to have cluster support, you need to be able to somehow monitor your system from a headless environment. And this is how it looks from the IDE. So we have this view that can remotely connect to any application instance and be able to directly, for instance, attach a remote debugger. So there is a point, if you have enabled debugging for a process, you can directly from the IDE launch the remote debugger and attach to that process on any remote machine. So there is no further information needed. It's everything calculated from there. So my conclusion to this topic is that it really, really pays to have developers that care about the IDE and the environment. So everything that you can improve in the workflow, it has a multiplication factor somehow. The more people are in there, the more benefit you gain from really investing, getting your hands dirty, develop some extensions for the IDE, and just have a look at your processes, at what people do, and try to improve their lives. And the bad side of not doing this, not investing in there, would be that everybody is doing it by himself. So if people are unsatisfied with their IDE, they're going to look for external tools, update sites, install stuff, and you're completely inconsistent in 5 minutes. I can guarantee it, nothing will actually work anymore. Don't fear Eclipse internals. Start a debugger, debug the platform, debug the IDE, have a look at what's happening in there. Sometimes the solution is really simple for scalability problems. And what we also saw, there is no one-fits-all recipe for scaling. So there is no tip that I can give you that would guarantee that you're successful in scaling. Because every software is different, every setup is different, processes are different. So everybody needs to find his own way through the scalability hell. And also the conclusion, Eclipse can scale and our software can scale. We can scale with Eclipse, so it's a great tool. It works for us perfectly. And we have actually no more huge pains with it right now, so we're happy. And I think that's it, more or less. Are there questions? Yes?
You said that you have all 800 plugins in your workspace. I guess you mean also that the other projects are open.
Yes, our projects are open at any time. And even because otherwise nearly nothing would compile. So it's really a little bit of an architectural issue too, of course. We maybe have a little bit too many bundles, and maybe sometimes the distribution of the code amongst the bundles is not optimal. But basically, all the 800 bundles make up a single software. And we need nearly everything. So as soon as you start launching the application, you need everything. It's that way. And of course, all are open because otherwise nothing would work. Yes, we have the target platform. We actually experimented with putting stuff in the target platform. So maybe splitting out the platform part of our software and delivering it binary with the target platform. And we actually failed on this. So we had an experiment, or we actually had that productive. And it didn't work because it was too much of an overhead, and too often people discovered that they need something from the platform or need to change something in there, what's binary now, and then they weren't able to do this, or it was too much of an effort. But that's one of the points that we implemented, I think, last year. You can see it on the timeline. These are the binary plugins. And so what we did was we implemented some IDE extension that allows you to convert. Did somebody hear the eBay talk on this? There was a talk a few years ago. eBay did this, and they promised to open source it, and they didn't do it, so I wrote it myself. So it basically provides you the capability to convert any plugin that you have in source in your workspace into a binary representation by exporting the jar file and then removing the project and stuffing the jar file as binary project, so Eclipse can handle this, into the workspace. This saves some time, especially for the builds, and you can easily convert it back to source whenever you need it. So we have this, but it's not really widely used. We have too many changes in too many areas in too short time. Yes?
Is it Power Builder or replace it with Tycho? So if I have a Power Builder Tycho today, do I get to lose that and replace it completely with Power Builder?
For us, yes. So for us, there were a few requirements that were, I mean, you also need to take into account that we built that like, when was it? A few years ago, 2011. So back then, technologies looked a little bit different. There was no Tycho. Maven was not well suited for us because we have a strict offline requirement. So we must be able to reproduce every build completely offline because warehouses, they don't really understand why they should have an internet connection to move their box from A to B. Yeah? So they typically don't have anything like that. So if we're on site and installing our application and building our application, we must be offline capable. And back then, there was no really good possibility that we found to mirror repositories and carry them around and stuff, apart from zipping up the local cache in your home directory, something like that. So we went with this. And it's pretty easy because it uses what's there already. It just exposes it in a different way. Yes?
Your IDE is currently behind your target platform with the diagram. Is that because, why didn't you move your IDE up to 4.5?
That was for the Mars IDE, yes. We had the IDE still on 4.4 because we didn't manage to upgrade in time. Right now, we are on Mars.2. And since Mars.2 is not really satisfying on Linux, with the GTK issues, we're switching to Neon very likely right in 2 weeks. Something like that. Any more questions? Then thanks for listening, and if you want to talk to me, I'll be outside.